In this video, we're going to learn how to calculate the pH and POH of a strong acid and a strong base. Alright, so let's begin with knowing what the pH scale is all about. It is simply a scale used to measure the degree of acidity or alkalinity of a substance. Okay, now note that when pH is less than 7, the solution is said to be acidic, whereas when pH is greater than 7, the solution is said to be basic. Alright, when pH is equals 7, the solution is said to be neutral. Alright, so take note of these intervals, very important. Now, in acid and base chemistry, pH is defined as the negative log reading to the base 10 of its hydrogen ion in concentration, whereas POH is defined as a negative log reading the base 10 of its hydroxyl ion in concentration. Alright, so note again that hydrogen ion is the same thing as hydrogen ion. Alright, so these two terms mean the same thing. Alright, note again that in aqueous solution at 25 degrees Celsius, the pH and POH sum up to 14. If we know hydroxyl concentration, we can calculate the pH. Alright, so what it means is that pH plus POH sum up to 14. Alright, because in the pH scale it ranges from 0 to 14, but so pH plus POH will sum up to 14. Okay, so let's wipe this now and solve a typical problem on this. Okay, so let's look at this question. It says calculate the pH and POH of 0.005 mole barium hydroxide. Alright, so this barium hydroxide, let's rewrite the equation or the reaction. Barium hydroxide, right, will decompose to form 1 mole of barium ion, right, plus 2 mole of hydroxyl ion. Alright, that means by the mole ratio of 1 is to 2. Alright, so this is 2. Now to get the hydroxyl ion, it will be the mole ratio of hydroxyl ion in this reaction times the concentration of barium hydroxide. Alright, so the hydroxyl ion concentration now will be 2 times 0.005. Alright, so which will give us, let me punch it to my calculator, it's going to give us 0.01 mole. Alright, so this will be the hydroxyl ion concentration. Now that we have gotten it, let's find the POH. POH is negative log to the base 10 of hydroxyl ion in concentration, so it's going to be minus log to the base 10 of the hydroxyl ion concentration is now 0.01 mole. So let me punch it in my calculator. Okay, so if you punch it with your calculator, you're going to have it to be 2. Now that we have it to be 2, remember to get the pH plus POH equals 14. So impute the value of the POH. So it's going to be pH plus 2 equals 14. Make pH the solid formula. This 2 equals to equality sign and it will change to negative. So pH now equals 14 minus 2 will give us 12. Alright, so it's as simple as that. Let's wipe this now and solve another problem. Okay, so let's look at this question. It says calculate the hydrogen ion concentration and hydrogen ion concentration, pH and POH of 0.02 mole of tetrahydrosulfuric acid solution. Alright, so let's begin with this tetrahydrosulfuric acid solution where this is 2. We decompose to give 2 moles of hydrogen ion concentration, Y plus 1 mole of sulfate ion. Alright, so this is what we're going to have. That means we have a mole ratio of 1:2:1. Alright, now to get the hydrogen ion concentration of this reaction, you multiply the mole ratio of hydrogen ion by the concentration of tetrawatt of acid in this solution. So the concentration there is 0.02. So when you multiply it, it's going to give you 0.04 mole. Alright, okay, so this is now our hydrogen ion concentration, 0.04 mole. Now that we have gotten it, let's find the pH. pH equals negative log reading to the base 10 of this hydrogen ion concentration. So it's going to be negative log to the base 10 of, okay, we have the hydrogen ion concentration to be 0.04. Let me punch with my calculator. So it's going to give 1.39. Alright, if you want to leave it into decimal, one decimal place rather, it's going to be 1.4. Okay, so this will be the pH of this solution. Now let's get the POH. Remember, pH plus POH equals 14. Then impute the value for the pH. We have 1.4 plus POH equals 14. Make POH the square formula. This is equal to the equality sign. We're going to have POH equals 14 minus 1.4. Alright, so it's going to give us, okay, if we do the math, we're going to have 12.6, and this will be the POH. Now lastly, let's get the hydroxyl ion concentration, the OH ion there. Let's write these parts. Okay, so for the hydroxyl ion concentration, remember POH equals negative log the base 10 of this hydrogen ion concentration. I have a POH. POH there is, we have 12.6 equals negative log the base 10 of hydroxyl ion concentration. So to make hydrogen ion concentration, the shortest formula, divide both sides by negative log the base 10. Alright, negative log the base 10. So this negative log the base 10 cancel this negative log the base 10. And we now have our hydrogen ion concentration to be the log inverse of minus 12.6. Okay, let me punch log inverse of minus 12.6. So it's going to give us 2.51 if I leave it into decimal places here times 10 to the power minus 13 mole. Right, so this is 13, and this will be the hydrogen ion concentration of this solution. Alright, 2.51 times 10 to the power minus 13 mole. Let's wipe this and solve one more example, a random question before I call it a class. Okay, let's look at this problem. It says analysis of table 1 made from local foods has concentration of hydrogen ion to be this value. Calculate the hydrogen ion pH and POH, right, of the solution or concentration. So since we have our hydrogen ion to be 3.85 times 10 to the power minus 6 mole, then the pH equals negative log the base 10 of this hydrogen ion concentration. So it's going to be negative log the base 10 of 3.85 times 10 to the power minus 6. So let me punch in my calculator. Okay, so it's going to give 5.41. 5.41 if we are leaving it in two decimal places. Alright, so now that we have the pH, you get the POH. Remember, pH plus POH equals 14. We now have the pH. That's when you put the value, it's going to be 5.41 plus POH equals 14. You make POH the solid formula. This way, cross over the quantity sign. Going to have POH equals 14 minus 5.41. So let me punch it in my calculator. It's going to give, okay, 8.59. Now that we have the POH, to calculate the OH, the hydrogen ion concentration, we're going to make use of, so we have POH equals negative log to the base 10 of hydrogen ion concentration. So let me write below and solve it. Okay, so the POH is 8.59 equals negative log to the base 10 of hydrogen ion concentration. So to make OH ion, the solid formula, divide both sides by negative log to the base 10. Okay, negative log to the base 10. So this cancels it. Therefore, our OH ion concentration will be the log inverse of minus 8.59. So no punch log inverse of minus 8.59. Okay, so I have it to be 2.57 times 10 to the power minus 9. If you are leaving it into decimal places here, mole. And this will be the hydrogen ion concentration for this analysis. And with this, we have come to the end of the class. Hope you learned something interesting. This is basically you can do calculations on pH and POH of strong acid and bases. Right? Find their respective hydrogen ion concentration, hydrogen ion concentration, pH and POH. Alright. Thanks for watching. If you are new to the channel, be sure to subscribe for more videos. Like, share, and comment on this video. Tell me how you feel. If you seem to have any specific questions to ask, feel free to leave your question in the comment section below, and I'll be sure to give a response. That's it for this class, guys. Thanks for watching.